Cool. So everybody, welcome to PL Talk. This is a weekly live stream on Fridays at 3 p.m. Pacific, hosted by Hongi and me. I'm Jean. I am the founder and CEO of a company called Akita Software. We're making API tools to make you make better software. Hongi, do you want to introduce yourself very quickly?
I'm Hung Hu. I do security at Figma.
And PL, oh, sorry.
Should I intro myself or no?
We were gonna do an intro of you.
Throw to you.
Yeah, sorry. So PL Talk came about because I think I tweeted at Hongi we should do a Twitch stream, and we didn't know what we would Twitch about. And Hongi, suggested the first topic, and it kind of went from there. And so we're very excited. This has led us to here. So it started with us discussing like one programming languages paper. It led to people just suggesting other things. I think our second session was about how to make programming languages more accessible. And what is more accessible than static types for dynamically typed languages at a company that everyone knows about, of a language that everybody knows about, than static types for Ruby from Stripe. And so this brings us to the introduction of Nelson.
I'm a software engineer. I was at Stripe for about 7 years, working mainly on developer tooling and kind of infrastructure tooling there. I've worked on a whole lot of stuff in my career, from the Linux kernel through to infrastructure at Stripe to building a static type checker at Stripe. Mostly with theme of relatively low-level infrastructure stuff, and a lot of work on developer tooling in general, kind of tools that other people use to get work done. I was one of the 3 engineers who founded the Sorbet project at Stripe to bring static types to our Ruby code base, and that's what we're going to be talking about today.
So we're super excited to have Nelson here because I think people have been really excited about hearing about Sorbet, learning what lessons can be transferred to other similar languages. So the structure is Nelson will talk a little bit about what Stripe was like before Sorbet, and also just include some of his other background if that's relevant, give the motivation for Sorbet. Hongi has been really good about making us like zoom out and like tell people what does it mean to talk about like static types for dynamically typed languages. Why don't you just start with a statically typed language? What's the point? So we'll get into some of those questions. And then Nelson has a bunch of demos prepared, and then testimonials, bugs they found, all kinds of other stuff.
Yeah, sounds great.
Yeah, so we started building Sorbet, I think in late 2017 at Stripe. When we started, so if you're not familiar with Stripe, it's pretty well known these days, I guess, but it was a brief intro. We are a online platform for accepting payments, primarily or largely developer focused, really focused on having an API that people can use to plug credit card payments, et cetera, into their website. When we started working on Sorbet, Stripe was implemented, still is, almost entirely in Ruby, in a multiple million line Ruby monolithic monorepo. I keep wanting to call it a monorail, which was Twitter's term for their Ruby monolith. So we had hundreds of engineers working on this multi-million line Ruby code base that was moving, billions of dollars around. And we kind of, as we scaled, as we added engineers, as we kept increasing the pace of feature development and size, kind of faced the question of what things we needed to do to keep developer productivity up, to make it easy for people to work in this code base and understand the code. And we decided to, among many other projects we took on, to graft a static type system onto Ruby in a similar style to a couple of other pieces of work that have been done. Dropbox productionized the MyPy tool for Python for similar reasons, and the TypeScript and Flow projects at Microsoft and Facebook did a kind of similar project for JavaScript. So we wanted to gradually add static types and static checking onto our millions of lines of Ruby to enable our developers to work more easily, safely, and quickly in that code base.
Nelson, could I ask you to briefly describe how typing works in Ruby for folks who might not be familiar with or may not have written any Ruby before?
Yeah,
like
sure.
Very brief.
So Ruby, if you're not familiar with Ruby, it's a it's a dynamically typed, very dynamic interpreted language. It's similar in many ways at a high level to Python or JavaScript. So it has a rich notion of types at runtime. If you're running a program and you have an object, it's object oriented. You can ask it, what class is this an instance of? Is this a string? Is this an integer? Is this a list? But none of this is declared or checked statically at the kind of source code level. It all just sort of happens as the program runs. Again, in a very similar way to Python or JavaScript without one of the typing systems that I've mentioned. So it actually has this, because of the way it's object oriented, it has a pretty rich notion of what types are at runtime, but it doesn't know any of that until the program actually runs by default.
Cool, thank you.
Yeah, do you have an example of just like a couple, like one or two kind of issues that you guys ran into before?
Yeah, so I think the biggest reason that we ended up building, so I'll show some actual bugs that Sorbet found once we get to a little bit. But I think that I want to say the biggest reason we tried to build static typing was less around catching specific classes of bugs or preventing specific classes of bugs, although that was certainly one of the motivations. But it's more that we thought it would make code easier to understand and to reason about. Because when you're in a large code base, you spend a lot of your time working with code that you didn't write, that someone else wrote,
Yeah.
someone on your team or even someone on a team kind of somewhere else in the organization. And our experience and experience from people at other companies was that at this scale, being able to express statically kind of in the source code in a way that was checked by the computer, this thing expects a string, this thing expects an instance of this class, having that as part of the interface in the code just made it a lot easier to kind of quickly grasp and to reason about code, especially code that you don't write or don't work with every day. It also enables much faster feedback in your code. People sometimes talk about the kind of relationship between testing and static typing, because in some cases they find similar classes of issues, right? If a function expects an integer and you're calling it with a string, a unit test can potentially find that if it executes the code, and so can a static test, and so can a static type system. One of the big reasons we were excited about static types was getting that feedback faster. Stripe had and has an extensive test suite, and we a very sophisticated continuous integration environment that I also worked on that ran tests on every push to GitHub and that people used when developing. But as we scaled, running all of the tests got really slow and expensive. It usually took between 5 and 15 minutes to run the entire test suite. It kind of got slower as people added code, got faster as people optimized it, et cetera. Whereas Sorbet eventually was able to check the entire code base in about 10 seconds from a cold start.
That's
and
incredible.
even faster once we added various optimizations in IDE support, et cetera. And so even if it were the case that the tests were servicing the exact same set of issues as Sorbet, which is not true. I think static types can surface things that they make it so you don't have to write certain tests.
Yeah.
But even if you're getting the exact same coverage, a static checker can work so much more quickly that it can give you kind of initial feedback on your code much faster. And eventually, Sorbet actually supports the language server protocol to give you feedback directly in your IDE. And so you can look at code, you can see exactly what it expects, what type it expects, and you can get feedback much faster as you're working than without static types. So those were kind of some of the big motivations for why we wanted this, why we thought that this would help people work faster and with more confidence, more so than specifically wanting to catch no method errors, which is what Ruby calls it when you call a method that doesn't exist. That was also a concern. I want to be clear, but that kind of wasn't I think the biggest driver. The biggest driver was we thought it would help scale the human process of working with and reasoning about source code in a large organization.
Cool.
That's awesome.
That's really
Yeah.
clear. Thanks, Nelson.
If I can just, I was going to say one quick thing is that I actually lived through the Dropbox times of using MyPy and actually typing the code base there. So everything that you just said was pretty much the exact same thing that happened to Dropbox.
Yeah,
and I think motivate was the same. Yeah.
And actually, that gets a little bit into one of the questions I just saw from chat, which asked whether we read papers about gradual typing and related ideas and kind of what prior work we looked at. One of the we looked pretty extensively at the prior work here, and we talked to people who'd done this before. On the practical experience side, one member of our team, Paul Tarjan, had worked on the Hack project at Facebook, which was Facebook's project to add types to PHP. And we actually came over to Dropbox and had lunch with Yuka and Guido, who were the two leads on the MyPy project, and kind of grilled them about their experience, what they had learned, what had gone wrong, what they had to teach us. And then the third member of the founding team was Dmitry Petrashko, who did his PhD in programming languages. And so he was extremely well-versed in all of the literature and kind of knew basically everything that academia has to teach us about the different type systems and different relationships between them and the various attempts at formalizing gradual typing or incremental typing. And we also looked briefly into the work of Jeff Foster at the University of Maryland, who had done some prior work on building type systems for Ruby. So we did our best to kind of understand all of the prior work and all of the ideas that we could find before we set out on implementing this in earnest.
Yeah, and just super quickly, it might be helpful to give an overview of like static typing versus gradual typing versus what Sorbet ended up being.
I feel like some of these terms are terms where people end up in flame wars about the exact boundaries
Oh yeah,
of
absolutely.
what means what. But kind of right at a high level, static types means that you have a program, called a type checker usually, that can look at the source code and figure out, either because it's declared or because it can do some kind of inference, what the type of every variable or method or expression is without actually running the code. And once you have this information statically, you can also sort of check that it's compatible. That if you are adding two things together, you're adding an integer to an integer, that's okay. You're adding an integer to a string, that's not okay. This idea of gradual typing or gradual static typing is this idea of usually used in the context of retrofitting types onto a dynamically typed system, although some people have proposed that maybe that's a fine way to work from scratch. But the idea of gradual static type checking is you can have a program where some parts of it are statically typed, that the types are known, that the type checker can look at it and say that that's a string, and other parts where the types are unknown. These systems often have a type that's called dynamic or any, which is basically the way of saying, we don't know what's going on here. We'll check it at runtime. We'll find it out at runtime. Statically, we don't know. With the idea being that you can write parts of your code, maybe the most stable parts of your code, maybe just the parts of the code where the team members like static types, whatever makes sense to you, you can get the benefits of static typing. But then in other parts of the code, you can get the kind of ease of development and flexibility and freedom of just sort of not writing down your types, of just sort of hacking things out, experimenting, iterating very quickly, and then ultimately at runtime everything will get checked. But you kind of can choose the best of both worlds when you're working on the code base.
Cool. Yeah, that's a great description. And then it's my impression that Sorbet is mostly static and not gradual. Is that true?
What do you mean by that question? Or
is that it's like you're mostly focused on static checking and not necessarily combining the static parts with like dynamic?
No, I think I think Sorbet is very gradual
Okay.
because
Okay.
we were
Oh yeah, I didn't
starting
realize that.
because we were starting with millions of lines of existing code. It was really important that we be able to add types incrementally, right? Like
Okay.
when we started rolling out the project, there was literally one source code file out of maybe 40,000 Ruby files that had
Yeah.
types in it. But the
Yeah.
Sorbet checker would still consume the entire code base and to check as much as it could.
Yeah.
And actually, this maybe gets to another thing that we built as part of Sorbet was we actually built a runtime type checker as well.
Oh wow. Okay. Okay. Yeah, that does sound pretty gradual. Because something that was surprising to me was we dug into flow at Facebook, and actually it's like very much a static checker, like not gradual at all.
Yeah, so Sorbet was aggressively designed because of the problem we had. We had these millions of lines of code that we wanted to gradually add types to support code that had types and code that didn't have types in the same program. And one of the things that we did do that was we built a dynamic type checker where we would use Ruby's metaprogramming features to actually wrap methods in helpers that checked the declared types at runtime.
Oh, that's amazing.
So if your method says I accept an integer, actually at runtime we'll insert a small bit of code that verifies that this is an integer. And the reason, one of the reasons that that's important is that means that when you're writing in typed code, if you write a type parameter that says this thing expects an integer, you can be guaranteed that that's an integer, even if your code is consumed by untyped code. Even if other people are writing code that isn't covered, that doesn't have declared types, that isn't covered by the type checker, kind of you enforce at your interface boundary that if I don't have an integer, I'm going to raise an exception and blow up at runtime, and so I, the programmer, can get the guarantee that this code has the types that I declare.
Cool. Yeah, should we get into some demos and then circle back to some of the questions?
Yeah, I see a couple of questions in Twitch that I'm going to answer pretty quickly.
Perfect.
I don't believe we looked at. Someone asked if we were influenced by Julia's work. I don't believe we specifically were. I imagine that Dimitri had some familiarity with it, but it didn't come up in the things that we discussed as a team. Checksor asks if we have any lessons learned from the implementation of Sorbet. There's quite a few. I'm happy to dive into implementation if kind of later on if that's a topic of interest, but I'm actually just going to cop out a little bit and link to my blog where I've written several posts about Sorbet. Just search for Sorbet in the archives, and I wrote a couple of pieces about some things that I thought went well and techniques that we used that I think might generalize. And then the last question, yes, the runtime checking you only get if you kind of use our type declaration syntax. If you declare, there are ways that Sorbet lets you declare types in comments or declare them out of bounds, and we don't type checks in that check. We don't check types in that way. So I think that's actually a great opportunity to jump over and share a screen and just show off some quick demos of what Sorbet code looks like and kind of some of the issues we found with it, et cetera. So this is the Sorbet Playground. I'll post a link into Twitch chat, but we actually have it set up so you can run Sorbet in your browser. You can drop Ruby, you can put Ruby code in there and see what Sorbet thinks of it. This is kind of our default example that we have loaded. You can see a couple of things here. This syntax here is our typed syntax. We made the design choice when building the Sorbet not to change the language, the syntax of the Ruby language. And so our types are actually represented as DSLs, the declarative syntax within the Ruby interpreter that the normal Ruby interpreter can consume, and it will call into our implementation, but then kind of otherwise mostly ignore. We made this choice because changing the syntax of a language has a lot of implications for tooling that you use. We didn't want everyone's IDEs to have to learn to syntax highlight our new syntax. We didn't want our linters and formatters and whatever other tools we had. We didn't want to have to change all of those. And we didn't want to have to patch the interpreter or add a separate compilation stage to our build pipeline. So Ruby, we are actually now working with the upstream Ruby language on kind of more native support for typing in Ruby 3, and that will probably come with optional syntax changes, but we made the choice to work within the Ruby syntax. And this is a place where the expressiveness of Ruby syntax and the kind of number of different ways it lets you spell things and write things came in handy. So this is a basic example of, this is a method. We declare that this parameter here, x, is an integer, and it returns a string. And then in Ruby, 2_s is the method that takes an integer and parses it as a string. And then we can just show here that, simple typos, if we mistype the name of this method, it says that that method doesn't exist. Maybe you want this other method bar. And if we pass it a string instead of an integer, it gives you the error. And this playground is also showing off on the right here is what you, all right, we'll bump, I think, all right, that's this, on the right here is what Sorbet would show you if you just ran the command line binary statically on the runtime. Or on the command line on a Ruby file. And on the left here, we're showing off the IDE experience. This left is actually talking to the Sorbet language server protocol behind the scenes. And so you can see that when I hover over things, we get type annotations. When I hover over 2s, it actually pulls the doc string from the standard library. We get these red underlines, and if we edit the code, the corrections disappear in real time. That was a relatively late. The IDE server was the IDE support was a later addition. We built that after we had built out the core language, but it's also something that we knew from the start we wanted. That having both having a type system that lets you understand that almost everything in Ruby has a 2s method. And so in order to know which 2s method this is, we actually have to know the type of x. And so we have to have types in order to have this level of kind of accurate documentation in the browser. I see Jez has joined the Twitch chat. He is another member of the Sorbet team. He was actually the first person to join the team after the founding. So he also came on pretty early and contributed to building a lot of the stuff that I have been talking about or will be talking about. Someone asked how we decided the playground was worth implementing so early on, which I'm going to answer because it's a fun story. About 6-ish months into working on the Sorbet project, we gave a talk at Ruby Kaigi in Japan, one of the big annual Ruby conferences. The Sorbet tool wasn't yet ready to be open sourced. We knew we wanted to open source it eventually, but we were prioritizing deploying it internally. And so we kind of had the question of, we've been accepted for this talk, we want to show it off, we know we're not going to open source it yet, but how can we give people a taste of what we've built? And so we decided to, a browser playground would be really cool. Like maybe we can make that work. And so initially I was like, all right, that would be cool, but it's not a priority. I'm going to give myself a 2-hour time box to see if I can get mscripten working from scratch in 2 hours. And so, then if it fails, we won't have wasted that much time on kind of our actual priorities. So I sat down, and the first version of the playground was built by literally a shell script. I threw out Sorbet's entire build system and just had a shell script that called mscripten, which is the compiler from C++ to WebAssembly. Didn't do incremental builds or anything, built everything from scratch and got the barest of bare demos going in the browser that, didn't have any of this LSP fanciness, just had a text box and an output text box. But we're like, great, we have a demo, we can bring this this to Kaigi. And then I think all three of us got nerd sniped and ended up spending the entire plane ride to Japan, polishing the playground and adding little features. And so by the time we got there, we actually had a like decently nice playground demo to show to the audience, even though we didn't have the open source thing for them yet. So the answer is kind of, we built it kind of on a whim, but then it turned out to be so fun and so useful that we couldn't stop improving it. One other thing I want to talk about that in this demo that is sort of a core feature of our tool is this typed true comment here. Again, getting to the incremental nature of our type checker. If we wanted to support code that was typed alongside code that wasn't typed, we made the choice that if you want your file to get checked by Sorbet, you have to opt in by adding this typed true comment. If we change this to typed false, you can see Sorbet still consumes this tool, but it's like, I'm not going to report any errors. You didn't ask me to. Importantly, though, when it's typed false, Sorbet is still parsing this code. It still is updating its internal model of the universe so that it knows that there is a class called A, that class has a method called bar, so that if a different file that is typed tries to call into this file, it tries to do a.new, that code knows that A exists, but it disables Sorbet reporting errors on this file. We also support an even higher level of strictness. We can go to typed strict, which has added a new error. In typed strict, every function must, every function and every I actually forget exactly which set of things, but the core thing is every function is required to have a type signature. So this is basically saying, I want to work in something that feels more like a fully statically typed language. And so in type strict, it gives us this error. And so that gives teams this ability to install a kind of a ratchet on their code. If they go and type everything, there's a way to declare, this code is typed. We're going to continue requiring that all new code has types. No, one of these slides has a talk through of all of our strictness levels, but I have lost it. Oh, here we go.
Oh, it's right there.
Yeah, this one. So we have 4 levels. Kind of no comment. Typed false is actually, I guess, I don't remember anymore if typed false is the new way of doing it because these slides are old, or but these slides are a little old. I think the system has changed a little bit since then, but by default, we do read all code, and so we'll report syntax errors everywhere, which even just reporting syntax errors, great. Jez has dropped a link in the chat on the current documentation on strictness levels, which have changed slightly from here. But even checking syntax errors in untyped code turns out to be appreciated by developers. Because the Sorbet tool is so fast, we can actually parse and type and just like do basic type checks and syntax checking on the code base much faster than the Ruby interpreter can load the code. So in many cases, Sorbet is the first way that developers find out even about simple syntax errors and things that Ruby itself could find out. At the next level, we enable type checking, and we go up a level. We require instance variables and functions to have types on them. And then typed strong is still a little bit aspirational. It's not really supported. But the goal is that in typed strong, you won't even be able to call into code that doesn't have types. Kind of in a typed strong file, every variable and every expression and every function call, Sorbet has to be able to figure out the type or it will give an error. That's the level that the idea is that would feel like writing in a more traditional statically checked language where literally everything has a type known at compile time.
And Nelson, there's a question about the overhead of the runtime.
Yeah, there's a question about the overhead of runtime type checking. The answer is a little bit complicated. We checked that in most cases, the overhead is pretty small. We saw 1% or so on our use case. The runtime type system does support deep type checking of collections. So for instance, if you pass a list and you declare this is a list of integers, the runtime supports optionally actually iterating over every element of the list and verifying that it's an integer. If you have large lists, this gets quite expensive. And so at Stripe, we have tests in our CI environment that actually run various key pathways and measure how many type checks are happening at runtime and error out if type checking is getting too expensive. And Jake reports that we actually just deleted the feature of deep type checking for collections because it has the potential to be so expensive. So the answer is there are, I think with that change, there are fewer problems. There are a few possible foot guns where you can stumble into type checking being very expensive, but normally it's pretty cheap.
Cool. Do you do any? Oh, sorry. Go ahead.
Oh, sorry, I forget if I said this before, but I actually left Stripe about a year ago, and I've been taking some time off. So the Sorbet project has been continuing quite actively, and so I'm a little bit behind on a couple of the details. And someone asks if we can turn type checking off entirely at runtime to make the runtime impact null, so that it only happens in CI and statically. We do have no, I have all of the talks we've ever given open. Here we go. So we do have a number of escape valves. You can add this checked false helper to a type signature, which means don't check this at all at runtime. I don't believe Sorbet currently supports a blanket flag to disable checking at runtime, but Jake can maybe answer if we've added that recently. But for specific methods, you can certainly declare, I don't want to check this at runtime, just rely on this statically.
I was going to ask, do you, or are you able to do any, or do you do any type inference?
Yes. So the way Sorbet works, we're jumping back to the playground here, is we do local inference. So within the body of a method, we do moderately sophisticated type inference, although it's sort of one pass and forward only. So, but at the level of a method, we require types to be declared. So this bar, the only way that this will get types is if someone declares the types. But within this, I can say, so we have this handy helper reveal type, which just raises an error that tells you the type of any expression, which is useful when playing with the type checker or debugging things. And so, we know that X is an integer. And that's not just for literals. If we do math on them, we still know that it's an integer. And Sorbet knows that knows that 2s returns a string. We can assign it to a temporary variable and then return that. And Sorbet also infers that this is a string. So within the body of a method, you generally don't have to declare types. We have a syntax too. If you want, you can say t.let is our way of declaring local variables. You can say let x be an integer, and that then fixes the type of x. So if we later try to reassign x, now Sorbet complains at us that x was declared to be an integer, but you're trying to set it to a string. If I didn't do that, Sorbet allows types to vary through the body of the function. So it's perfectly fine for x to be an integer here, and then for x to become a string. Sorbet can track that just fine.
Nelson, there was an interesting question in the chat that also has to do with how gradual is Sorbet, which is why is it necessary to have runtime checking?
Yep. We have some slides that I'll try to find and pull up, but the basic idea is because we support mixing typed and untyped code, we want to give the guarantee that inside typed code, you can trust types. So if you write, bar and, you say that X is an integer, and then someone does unsafe here is the escape hatch from our type system. It basically says, treat this as dynamically typed. Don't do any checks on the result of this. So this could be in a different file that didn't have type checking. Sorbet will let us write this. And so now it's possible to call bar here with a string. And we decided that what we wanted was that, if I'm the author of this bar method and I have declared that I am an integer, I want to be able to rely on that. I want to be able to write code in here that assumes X is an integer. And because this code can be called from untyped code, the way to enforce that is that we have to actually check it on entry to this function. Another sort of non-obvious reason, but that is related to one of Sorbet's a little bit subtle but more powerful features, is Sorbet actually has a moderately sophisticated kind of dead code detection system / path-dependent typing. So So let's say that you try to write your own type checking. There we go. All right. There's a subtle bug for why the old version didn't show off what I wanted, but this shows up. If I try to write my own type checking, I say ISA in Ruby is how you check if something is an instance of a class. So, right, maybe the developer of this was like, I don't trust the type system, right? I'm gonna make extra sure and check that I gave a runtime. Sorbet will actually raise an error that says this code is unreachable. You have written code that, assuming that type, will never be executed, and therefore something has gone wrong. And so, in order for that error to be accurate, it has to actually be the case that this function can never be called with something that's not an integer. And again, the only way to enforce that is that we have to check it at runtime. And this unreachable logic is something that actually surprised me when I was working on Sorbet. Dimitri, who I mentioned was our kind of type system expert, implemented this feature, and I was for a long time skeptical of kind of whether it was useful, whether we should give errors on this. But it actually ended up being a pretty powerful tool to find classes of bugs that otherwise Sorbet would be unable to check. So this, for instance, this is a fun example of a bug that Sorbet can find because of that unreachability logic. Yeah. So so this code is some kind of normal code, pulls a random number, asks if it's greater than 0.5, and then sets this variable to a number. Sorbet correctly infers that foo is an integer because it's an integer on both branches. But let's say you maybe make a small typo, you forget the comparison with 0.5. In Ruby, random.rand returns a float, and in Ruby, floating point values are always truthy. If you have a conditional and you do an if on a floating point, it'll always take the true branch. Sorbet knows that, and Sorbet can actually say, look, you branched on something that's always true, so this else branch will never be executed. And it expresses that by giving you this error that this code is unreachable. And so this is a case where the sort of the awareness of types and their interaction with control flow lets Sorbet tell us that this code has a bug that it otherwise wouldn't be able to. And that feature, though, in order for that feature to work, Sorbet, we have to be able to trust the types that are written in Sorbet. Because we want to trust the types and because we have untyped code in the system, we have to check the types on entry to functions because we can't statically check the entire universe. I'll segue there into a couple of brief demos of actual code that Sorbet found when we first rolled it out at Stripe. It turns out that even before we had written very many or really kind of any types for our system at Stripe, where we first rolled out Sorbet and we just ran it on the code base with kind of whatever information it could extract from the untyped Ruby code, it was already able to find a bunch of bugs that we didn't expect. So this is one where someone had a rescue clause. This is a Ruby's exception handling mechanism where they're loading some JSON and they want to say, if it was invalid JSON, do here. And they typoed the exception class. It turns out that JSON has a parser error, but not a parse error class. Even without any annotations, Sorbet is able to figure out what classes exist in Ruby because those are just declared in the source code. They don't need to be annotated. And so Ruby knows that this class doesn't exist. And this code was happily running along in production because this file had never actually been invalid JSON. And so this line was never executed and the Ruby runtime didn't care. But Sorbet doesn't care whether or not the code was executed. It was able to prove that this was invalid. Similar one here. I think this author had been perhaps writing too much Python code. In Python, the way you instantiate classes is just with parentheses. It turns out that in Ruby, that's valid syntax, but it tries to call a function named argument error, not instantiate the argument error class. Same deal. This had never triggered, or if it had triggered, it had raised a bad exception and no one had noticed. Sorbet was able to pick it up. This is a case where Sorbet's nullability support is going to come into play. So we made a choice. So in Ruby, any variable can take on the value nil, which is sort of Ruby's equivalent to null in some other languages. That means, kind of nothing's here or no value. We made a choice when building Sorbet to explicitly model whether or not any variable or any type could be nil. So in Sorbet, types can only be nil if you explicitly declare them as nillable using t.nillable. And so this is a case where that feature found a bug. The load method on our database objects at Stripe returns either an instance of the class or nil if there's no instance with that ID in the database. Someone here was blindly loading the endpoint and then trying to call some method on it. And Sorbet was like, well, hold on a second. That webhook might not exist. Load could return nil. And then you're going to pass nil to a function that expected a webhook endpoint. This error is Sorbet has flow-sensitive type refinement to some extent. So if you just write the very natural code, this is kind of the normal way you would fix this code in Ruby, is you check if it's nil and then you raise an exception. In our framework, this user error will result in a nice 404 error to the user. Sorbet is able to follow this code, and it's like, all right, well, if the code is nil, we'll enter this branch. This branch never continues. Raise, ends execution here, and so that means that at this point, the thing must no longer be nil. And so Sorbet allows this to pass with no additional annotations. And then this one was another fun one where the dead code detection carried its weight again. So the case when in Ruby is Ruby's pattern matching statement. It lets you can put a value here, and then there's various valid types of patterns, including for classes, pattern matching checks whether the value is an instance of that class. The author of this code presumably wanted to check whether the variable they were given was either a charge or a refund. And so they used the double a double pipe operator, which means or in Ruby. However, that's not how Ruby does pattern matching. What this code actually ends up doing is it evaluates the expression stripe charge, logical or, stripe refund. Stripe charge is truthy, so the or never evaluates the right side. And this expression just evaluates to stripe : charge. And this pattern match only actually checks for stripe charge, but completely silently. Nothing warns or gives an error in vanilla Ruby. Because of that dead code detection, Sorbet was able to be like, hey, I don't know what's going on here, but something's wrong. This code can't be what you meant.
Well, so Nelson, I don't know if this is the right time to ask the question, but it's related to a question someone had in the chat. We had briefly discussed how much of the academic literature or PL theory you actually ended up using for Sorbet. And I'm super curious, especially because some of your analyses actually seem quite powerful. Like what was useful from PL theory, what was not useful, how did you have to adapt things? And like how fancy are your underlying analyses? Are they just like really cool heuristics, or like are they...
yeah, it's a good question, and it's a question I don't have a super like neat answer to. I think the vast majority of Sorbet, we were deliberately a little bit conservative in the design of Sorbet. We didn't want to support super fancy type systems. We didn't want to support super fancy topics. Both because we wanted Sorbet to be relatively easy to implement. We wanted to, be able to ship a working implementation to our users as fast as possible, and because we wanted Sorbet to be fast. I mentioned that getting fast feedback was important, and while it is absolutely not the case that every complex type system ends up being very slow to type check, but many complex type system features end up having real performance costs because they require, complex unification or searching or other features in the type checker. And finally, we wanted Sorbet to be easy to understand for our users. And most of our users weren't type theory hobbyists, had never worked in a richly typed language. Most of them had some experience with something like Java. And so we wanted something that that when it gave errors, they would understand the errors pretty readily. And we cared a lot about generating nice errors and easy to understand errors, and generating good errors for complex type systems, higher kinded types, etc., is sort of at best a cutting edge research problem in a lot of ways. And we wanted to avoid solving research problems as much as we could. So at its core, Sorbet is relatively simple. We have a pretty vanilla type system, nominal type system of subclassing, etc. But I will say that one thing that I was super impressed by working with Dimitri, again, who is our kind of main type theorist, although I've long kind of enjoyed compilers and type theory as a bit of a hobby. I went through a Haskell phase like many of us do. But Dimitri was deeply versed in it, and knowing, kind of being well versed in the literature, I think helped him identify a lot of dead ends much faster than we otherwise would. A lot of things in type theory have subtle interactions of if you add two different features to your type system, things mostly work, but then some corner becomes ill-defined, or the complexity explodes in some corner. And Dimitri, just by being kind of well versed in the entire literature, was able to just cut off a lot of those dead ends very quickly. The last thing, the flow sensitivity in Sorbet is, I think, the most sophisticated thing we do. I think it is something Dimitri in part invented based on some other prior work. We actually talked at some point with Jeff Foster, who had done previous work on Ruby, about whether or not there was a paper to publish somewhere in there. The underlying model is relatively simple, but I certainly haven't seen it kind of presented or formalized somewhere else.
Cool, and I think that's an awesome description of what I tell people about why they should learn about PL theory. Is you might not use all of it, but you can figure out what won't work.
Yeah,
much easier.
I think that is a great description of it. Can just tell you some things that they sort of just you could otherwise waste time beating your head against.
Yeah, so I asked people what they want to spend the last few minutes on. One person, there's 1 vote for metrics from the rollout, 0 votes for other things.
All right.
So I think yeah,
right.
1 out of 1 people.
Yeah, so a couple of things. So I'll talk a little bit about about sort of our timeline and kind of how we thought about rollout and some of the metrics that we had. This is sort of our broad timeline. We kicked off the project in October 2017. We actually gave ourselves a kind of couple of months, or really like a full month, to do exploration of prior art, and also Sorbet is written in C++. I'm not sure I had mentioned that before. And we were pretty confident in the C++ choice, but it's a less popular choice these days. And so we kind of wanted to be sure that we would be as productive as we hoped in C++. So we actually gave ourselves kind of explicit go, no go date after a month of work for, let's check in, see how we like C++, whether it's working for us. And we concluded that did. We started rolling it out. It was only a couple months later we were typing the first code in our repository and starting to run Sorbet, and then we did a kind of gradual rollout. The rollout was very gradual. We wanted to make it really easy to roll out bits of type some places. We wanted to make it as easy as possible and non-disruptive to other people. I think the thing I want to get to was, so for one thing, we built a lot of tools to bootstrap type coverage. So for instance, we built this suggest types mode, which would basically see for every file in the code base, what is the current strictest level that file would pass type checking at, and then optionally just add them in place. So if files were already typed clean, you could ratchet them in and say, all right, this file is currently clean. Let's enforce it to stay clean. We built tooling to figure out what the most impactful things to type were. So for instance, in this expression, in order to type check this, we have to know the type of foo. Because of the way we require methods to be declared, if we don't have a type on foo, we don't know what the type of foo is, so we definitely don't know what the type of foo.bar is. So we actually built an internal tool that, as it went, would basically track where untyped values were coming from and give us a list of, if you type this method, it'll add this many more types to this much more types to our coverage. And we added suggestions so that we could guess types in some ways. Sorbet won't, like I said, Sorbet will not automatically infer types for methods for you for a couple of reasons. Some of them are technical, some of them are philosophical, but it turns out that a simpler version that sort of guesses signatures and then proposes them to you, and it doesn't do this recursively, importantly. So if you have methods that reference other methods, it kind of doesn't chase the types recursively. We can do our best to guess types for the simple cases, and then in the hard cases we can just give up, and that's fine because we don't promise to. But so for the simple cases, we can just guess your types for you, have a human review them, and then add them. But so you don't have to type them yourselves. So I wanted to show kind of a couple of graphs of the rollout. This was a graph of the first 6-ish months of the rollout, one of the dashboards we had. We were tracking how many files in our repository were typed, how many was the code base checking the types of, how many files were typed clean, but were not currently declared as typed : true. So these are files that Sorbet could check, but that no one had marked as checkable, or sort of Sorbet thought were fine. We could mark them as typed and keep them as typed, but no one had done so yet. And then this area up here are files that currently contain type errors. And In the early days of the tool, it's very hard to know whether these type errors are because they use a feature that Sorbet doesn't support yet, or they are correct but Sorbet doesn't understand them, or they're actually incorrect. These require some human to review. And so kind of one of the goals for the early stage rollout was just to drive these numbers up and to the right. Kind of had a little bit of an instance here where we redefined the strictness levels a little bit, and so we had to, or maybe we added more files that Sorbet was previously considering. So the metrics are a little bit noisy, but you can see that kind of here we started. So for here, I forget what feature it was, but we implemented some feature that caused 20% of files that previously had errors to no longer have errors. So we figured out what the most common missing feature was. We implemented them, and that kind of drove this line up. Then we gradually added types true to more files, and then eventually around here, we just made the tool, we did a massive commit that said every file that type checks today, we're going to set to type true, and it must type check going forward. This is a different metric that we looked at. This is function calls, or in Ruby's case, method calls, because Ruby only has methods. It doesn't have bare functions. What percentage of the method calls in Sorbet, in our code base that Sorbet looks at, does it know the type of? It knows the type of the left-hand side of the receiver of that method call. And we could track that going up over time as people added types to the rollout. And then we also tracked what is the number of type signatures that humans have written themselves, that humans have written into the code base. And this was a pretty cool one, because after our initial rollout where we did a bunch of auto-generated, almost all of this work here was not our team adding types. This was our users or people who were excited about types adding them to their own code. And so that was one kind of powerful indicator that you're like, oh yeah, people are using this. This is good.
Hey, Nelson, quick question.
Yeah.
The tools that you showed earlier, they're really awesome. And I was curious how did you surface them to developers? Was that like a thing, like feedback you showed them at CI time? Like, hey, this commit or this, PR that you have, you could type this and, here's some feedback on that, or did you expose it in other ways?
The kind of the suggestion, the guessing tools, we surfaced as a command line tool that users could run. They could run script spin type check. That was just kind of the layout of tools in our repository. And then there were flags where you could pass it to suggest more information. Eventually, once we got the LSP server, we could surface these in IDE, but initially it was just run this command line. And then also we as the developers could run it in various modes and review the output.
Gotcha. Cool. Thanks.
Well, so we're nearing the end of the time. And so I feel like, we have time for a couple more questions or comments. I don't know how you want, Nelson, it's your choice. You're the speaker.
Yeah, I'm happy to answer. We got some questions here. I can answer a couple quickly. Someone asked whether Sorbet can type lambdas and procs. That's how Ruby does anonymous functions. The answer is yes. I think we should have an example in here. So this is a function. This is a function that accepts an anonymous function, that accepts as an argument a function that takes an integer and a string and returns an integer. Sorbet can represent the type of that function, and it can check that we've passed the wrong thing to it. There's a question of whether more issues come from untyped code than typed code. Of can we demonstrate that typed code is raising fewer errors or is somewhat safer? This is something we talked about a lot and kind of wished we could show, but especially because you end up with these very deep call stacks that call between typed and untyped code, and because all of these metrics are very noisy, we were never able to show anything super satisfying there. I think kind of we talked a lot about how to find metrics of whether this code was whether this was working, whether it was accomplishing our goals, and it was frustratingly hard to find really good metrics that kind of showed clearly, yes, the code base is getting safer. I think the most compelling thing we found was we we made a real habit of talking to our users as we were part of the developer productivity organization. We ran surveys where we talked to users, we asked them what their complaints were, we asked them what they liked. And the feedback we got back from our developers was uniformly very positive about the type checker. People felt that it made them more confident writing code, that it was making them more productive, it made them more willing, more comfortable working in the code base. And so it's ultimately a little bit disappointing that we couldn't point at clear methods. We reduced runtime exceptions by 5%, but that was kind of one of the clearest points that our users were really appreciating the tool. And since ultimately one of our biggest goals was making it easier to develop code and making our users more comfortable developing code, that was pretty good validation.
Cool. So we are at the end of time. Nelson has loaded the chat. And so I don't know how free he is, but
I can hang around for a little while and answer further questions in chat if people still want to. And looks like Jake may still be around as well, who again is still actively developing on the Sorbet team, and so also has a lot of great information.
Yeah, cool. So everybody, let's give Nelson a thank you for coming on and demoing Sorbet and telling us about all the cool parts of Sorbet. And yeah, we hope to keep seeing. Next week, Hongi and I are taking next Friday off of PL Talk, and the week after we'll probably do a paper discussion again. I haven't discussed with Hongi yet, but I think actually discussing some of the gradual typing and like specifically Ruby work could be a really interesting like side by side. Yeah, maybe Nelson can come back. I haven't discussed with either two people. Maybe Jake can come too. We can have a 4-person discussion. Jake, I tried to invite Jake to surprise Nelson on the chat, but he didn't want to do that. But anyway, yeah. So thank you, everybody. Thank you, Nelson. And we'll be talking. Yeah, we'll be talking something probably maybe about gradual typing, maybe about Ruby. Not next week, but the week after next. Hongi and I will figure this out. Maybe we'll do some votes on Twitter. That's where that's where we hang out. And yeah, we will all be in the chat for a little bit. So goodbye.
Cool. Great.
And thank you.
See you, everyone. Thanks for all the great questions.